Now, everything that we've done so far was just a setup to show you the problem of the tight coupling. Let me show you what I mean. Let's say that you're building another use case and you want to work only at the core of the application. You don't care about the implementations yet. Okay. So what I would usually do in a, in a clean system like this, I would do this. Okay. So I would say, okay, today I simply want to compile everything that is inside of the core. Now let me actually close all the files. Okay. So let's say that I want to make changes to the report boundary. And remember, comparison has a direct dependency on the report boundary over here. Okay, so pretty much any change that I make here, right? Well, unless I just add a method, then the incremental compiler will be smart enough to simply recompile only this one code, right? However, in all of the other cases, right, like any change to the signature, change to the return type, even just a simple rename of the method, right? All of the components that directly depend on the boundary would need to be recompiled, and you will have compilation issues there. So let's run through a very simple scenario. Let's say that we wanted to not just return booleans. In fact, I opened the run one, right? I wanted the comparison boundary like this, right? So let me actually close the others, right? So any change over here would break the report boundary and all the other boundaries that would have a dependency on this one, okay? And by the way, let me create more space like this, okay? So let's say that we didn't want to just return a Boolean. Let's say we wanted to return some, a timestamp as well, right? So we're gonna have like a tiny case class over here, right? Final case class, we're gonna call the result. So we're gonna return our Boolean. I don't know how to call it, so I'm simply gonna call it Boolean, and we wanna return a timestamp, right? Which is gonna be a zoned date time. Okay, so we actually need to import it like this. Metals can do this for me. Great. All right, so let's go over here. Let's do this, and change this to result, and go to the next one and do the same thing over here. Okay, so now this means that over here, well, we need to construct a result, right? So this is going to be our Boolean, and this is going to be our timestamp. So we need to do zoned date time dot now, and in the build file, I enabled the explicit null thing, right? So yeah, over here it's not going to compile, and not because of this result, right? It's going to compile, not compile because of this null thing, right? So it's going to say I found zone date time or null, but I actually required only zone date time. Okay, so we need to do this dot and thing, which probably stands for not null, where we're basically telling the compiler to shut up. The downside of this is that it's going to throw a null pointer exception. Okay, if it actually turns out to be null, which is described exactly over here. Maybe I can actually do this. Yeah, okay, so if this thing is going to be null, then this is going to be throw a null pointer exception, right? But this is a nice and easy way to shut the compiler up. All right, so let me actually switch to problems over here, and let's actually do cascade compile. Okay, so obviously we have, this is exactly what I said, right? So we're breaking this over here, okay? So we need to do some like map, I called it Boolean, I believe, right? Like this, okay? Now we're probably gonna, we probably broke the tasks for the comparison boundary. Let's do a cascade compile. Yeah, there we go. So we broke the task. So yeah, over here we simply need to, hold on, do Boolean over here. There we go. Okay, so this should fix it. Let's go back to the terminal real quick. Everything compiles. Let's look at the diff real quick. Okay, so we obviously changed the comparison boundary, right? And this obviously triggered, some changes in the suite, right? However, what I want to have is I don't want to have this, right? I don't want it to touch other boundaries. So what I want to show you is a technique that will delay the compilation of the boundary, okay? And for this to work, first we're gonna revert all of my changes. I have an alias grhh, which comes straight from ZSH, it's not mine. So grhh, and all of these changes are gone. There we go. So what we're gonna do over here is we're gonna go to the gate of the report, and we're gonna make it a little bit more fancy. We're gonna say, okay, instead of just having a direct dependency on other boundaries, we're simply going to declare the things that we actually need, right? In fact, also, if the boundary has like 10 methods and we need only one, this is what you should do, okay? So we're gonna call it comparison, right? Comparison like this. And this one, therefore, will also be called just comparison, okay? Now, this one will therefore be called just comparison, okay? So this is going to be just comparison. Let me remove the cursor. There we go. We don't need this thing. We don't need this thing. We can go over here and say, simply say comparison star like this, or asterisk, whatever you prefer. There we go. Okay, and now this is the difference. Okay, so over here we're simply going to remove this one, and in the beginning we're simply going to steal the implementation from the real boundary, right? So the boundary that is for comparison, it has this method over here, so we're simply going to steal it, just for now, right? We're going to put it over here. There we go. Now, this obviously breaks the boundary, so we need to go there real quick and delete this thing, okay? So now there is no violation of the law of Demeter, right? So we're simply calling something on our direct, well, let's call it child, right? We're simply doing gate dot one method call, okay? Not gate dot give me some object and then a method call, okay? So if we go back to here. Now, if you wanted to compile the entire project, obviously it doesn't compile yet, right? We still need to implement this trait somewhere, right? But we're going to do this in just a couple of seconds. For now, I want to point out that now you have your freedom, right? So first of all, you can rename this however you want, right? You can change the input types, you can change the return types, you can evolve, this entire gate, this entire use case independently from that entire use case, right? I'm going to show this to you in just a couple of seconds. In practice, what you're going to have is that over here, you're going to return some really heavy case class, right? And this one over here, this boundary, it will require some different case class, right? So maybe the initial boundary has like a case class was like 10 fields, but you need only 2. Right? You can create it, and not only you can create it, you can actually use exactly the same name because it's under a different namespace. Okay, and the only place where you will create all of these conversions is going to be here, right? So you can rename this method, you can change the input types because you can adapt the input types before you call into the other boundary, and when stuff comes back from the other boundary, you can convert it. And this is where things like chimney and monocall and other, like macros-based things come into play. So let's add the implementation real quick, and for now, we're going to put the implementation exactly over here, right? We're going to move it in just a second, but for now, let's put it over here, okay? So I'm going to call it comparison implementation because I know that I'm going to move it, right? So right now, it's a companion object, so I could leave it like this, but I know that I'm going to move it in just a couple of seconds, so I'm going to call it impl right away, okay? So it's going to be called make, right? It's going to have the comparison boundary, which is going to be comparison dot boundary, and it returns the comparison like this. How's it going to do this? Well, same as always, new, and now it's going to do override, and we're going to grab this guy, paste it over here like this. How's it going to do this? Well, it's going to go to the comparison boundary like this, okay, and it's going to do dot, and we're going to grab this guy, do this, and it's going to be off like this, okay? Now, what the hell did I do there? Off like this, okay? Got an equal sign over here. There you go, okay? Now, you can work with exports over here, right? So you can also just do like, instead of this, right, you can just do export comparison boundary like this, right? But I don't recommend you do this, okay? So if we do this, it's exactly the same thing. But I don't recommend you do this because this is exactly the freedom that you want, right? You want to have a different name for this if you wish, right? You want to have, a different parameter list over here. You want to have a different return type if you wish, okay? So in the end, minimize the diffs, right? In the end, you'll probably end up changing things here all the time, right? Because this is just a contrived example, right? But in practice, you're going to have like probably some huge ADT over here, and it needs to be converted into another huge ADT over here. And by the way, this architecture does not force you to do this, right? So if you're kind of lazy or if you don't have enough time to convert like one huge ADT to another huge ADT, if you find it error prone, then on a per use case basis, you can decide not to do it, right? Because most of the time you're going to convert like a tiny case class into another tiny case class, right? But if you're dealing with some huge ADT, you can make the decision that for this use case, you're not going to do it. You're going to decide that you're going to have a tiny bit of coupling, okay? It's fine. All right, now if you wanted to run this thing, I believe one tiny part is still broken, right? Exactly. So let's cascade compilation, wait until we have an error, press F8. Come on, press F8. There we go. We're over here now, right? So we simply need to wrap this thing into a comparison, right? So we're going to do comparison equals comparison implementation dot make, open the brace over here, close it over there, and there we go. Okay, so now everything works exactly the same. And if it was a little bit too fast for you, check out the link down in the description below. This whole thing is on GitHub. We're going to upload it by the end of the video. We're going to call this one even better. Well, actually, let's show the diff real quick. Okay, so we have the law of Demeter. the gate looks slightly different now. The dependency injection is now wrapped into this comparison thing. It's very important. This comparison thing is defined inside of the report use case, right? It's very, very specific for the report use case, so you can do whatever you want in there, okay? So let's do gcam even better. There we go, okay? So this is our graph now. Cool. All right, let's go back here. All right, so now if you go back to the comparison boundary, right? If you were to introduce the same change, remember it was a case class and returning result instead of Boolean, we would break core only in one case, right? We would only break it over here, right? And this would be the only place we would say, da Boolean. It's very important that we're not going to introduce a change in the boundary. This thing will stay exactly the same, right? Because it dictates, right? This gate is very, very specific for this boundary. So it will return things in exactly the form that this boundary requires. It's specific for this. So the place to change stuff would be here, right? However, we still did not delay the compilation, right? So if we were to do this change right now, this trick was like just compiling the core, it would still fail, right? It would only fail here this time, right? But still. So what we're going to do is we're going to make this controversial step that I mentioned in the beginning of the video, right? Some of your colleagues might object to this, right? So if you look at our build, okay, we have our playground, which simply aggregates a bunch of things. Then we have the core, and we have the delivery, Google, and storage that all depend on the core over here, right? And then we have main that depends on everything else, right? So what we're going to do is we're going to add one more of these things, right? Right, because right now, for example, we could throw this comparison implementation, for example, in here, but this is not the right place, right? Why would you put it in there? It doesn't make any HTTP calls, right? Or you could put it over here, but why would you put it in there? It doesn't talk to the database. Okay, so what we're going to do is we're simply going to go over here, and I honestly have no idea how to call it. I'm going to call it core self, right? And also, it doesn't really matter much how you call it because there's not going to be a package that is called core self. The only place where this appears is going to be in the directory name. And by the way, guys, don't be afraid of adding submodules to your build. It's super easy to do, right? Just going to grab this guy, going to put them over here, right? How we're going to call it? Well, we're going to call it core self, which again, doesn't really matter. Okay, so we're going to go over here. It's also going to be on layer 2, right? So we're going to do this. It's going to be core self like this. It's going to depend on the core, right? And also at the very, very bottom over here, we're going to duplicate this line, find the D over here, and we're going to do core self, okay? Like this. Yes, sure. Import the changes. Let's wait just a couple of seconds. All right, let's do this one. Or in fact, we actually should do the other one to see that the whole thing actually compiles. In fact, let's do a clean and let's do this one, T main run. There we go, real fast, compiling all the project. Okay, so let me actually show you, so over here, this thing, right? And we can preview SVG. So it looks like this, okay? What we can also do is I can open this and I can do GD, no, hold on, how did I do this? GD, no, DG, okay, hold on, DG. LASDG is Bloop projects. Yeah, so Bloop. Yeah, okay, so there we go. So this one is going to remove the task. It's going to remove the playground. Yeah, exactly. Okay, so if I do this, yeah, there we go. So we just added the core self, right? So just one more. And by the way, notice that all of them are going to be compiled in parallel. This is really, really awesome unless you're on a laptop because it's just going to burn. But, technically this is exactly what you want. All right, so now we're just going to close this one and we're going to, well, let's actually close everything. Okay, so we simply need to go to the report gate, right? And we need to cut it out, right? So we're simply going to, well, let's actually create the file first. So we're going to move it to over here, right? So it's going to be a new file. All right, so it's going to be source main Scala dev inside you playground, and it's going to be for the report, right? And it's going to be called comparison.scala, like this. All right, so now we need to go over here, and create a package like this, and over here, and do a package like this. So now we need to the gate inside of the report, and we need to simply cut it out, save the file, okay, go back over here and paste it like this. Right? No new imports, no nothing. Like this is the beauty of these namespaces. I can very easily move these things around like this. There is a caveat though, the incremental compiler sometimes doesn't like it. I don't know why. sometimes blue breaks, metals breaks because of this, but it shouldn't. All right, so if you wanted to look at the diff, it would look very, very simple. We simply moved it, introduce another project for this. Okay, so now this is actually the best, like this. So now let's actually go and try to introduce exactly the same change as before, right? So remember, the use case was that we were staying inside of core and we were adding this thing to the boundary for the comparison, right? So we go to the bottom of the file, we add a final, well, not over there, I want it to be over here, right? Final case class result with a boolean, and a timestamp with a zoned time, well, zoned date, time, like this. There we go. Save the file, import that thing. Let's go to the boolean and change it to, no, like this, change it to result. Go over here, do the same thing. Over here, close the brace, result like this. And over here, we're going to have the zoned date, time, dot now, and NN, like this. Okay, now obviously it's going to break the tests. And why is it so hard for me to spell correctly? Result. There we go. Okay, so let's do a cascade compile. Wait a couple of seconds. There we go. Boundary suite, the same as before. Boolean. There we go. Okay, now it broke comparison over there, right? Because we cascaded the entire build. But SBT is fine because for SBT we asked to compile only the core, right? So if we look at the diff, right? So right now, look, we only changed something inside of the comparison namespace for the boundary, and over here, the same thing, comparison for the boundary, and the core still compiles, right? So you don't have these direct dependencies. In fact, this way you could even have cyclic dependencies. I don't recommend you do this, but you could, right? Because you have lazy vals at the very bottom in the dependency graphs. If you didn't have that and you wanted to have cyclic dependencies, which again is not something that I recommend, but if you wanted to, you would need to work with by name parameters. Over here, you don't. All right. Now, as promised, the only place where it is broken is exactly where it's supposed to be broken, right? So this is exactly the gate, and you fix it at the gate, right? It's sort of like you're working for the customs and you're paying a little bit of price, for the customs, right? So this is exactly where you're going from one use case to another. You're doing all of the conversions right here, right? So again, it's very important that when you look at the diff, okay, so even though now we changed over here something in the report, right? So a change in comparison led to a change in the report. However, it led to a change very, very low in the dependency graph, and it was exactly in the place where it's supposed to be broken. All right, so let me actually revert all of this crap. Now, I don't want to beat this horse to death, but imagine how relatively easy it would be to split up a monolith like this into multiple microservices, right? You wouldn't need to change the imports or the packages. You just simply move it to another thing. And well, you need to change the gateway because now it's going to be HTTP calls, right? But apart from this, like it's very, very easy. Like all of these conventions around names and namespaces. Really, I thought about this for years. All right, one last thing that I want to mention, and it's only vaguely related. It's about a question that a colleague of mine had. So a colleague of mine is worried about one gate being accessible from an unrelated boundary, right? So for example, let's say that we go to the report boundary over here, right? And we could say, give me another gate, right? Another gate from a comparison gate, for example, right? So at least over here inside of core, this would compile, and he really doesn't like this. He basically says, okay, if you wanna access the persistence layer, you should go through another boundary. And there's a super easy way to do this because of the way we're dealing with namespaces instead of packages. You can pretty much make everything private, like literally everything. The only thing that is not going to be private is going to be the comparison, and only those boundaries that you have dependencies on. Okay, so what we're going to do now is I'm going to literally make everything private that is humanly possible, right? So for example, this is the report boundary. Nothing has a dependency on it, right? So I can do private trait, okay? I can do private object, right? And it's still going to work, right? In fact, the entire thing is going to work, right? Let me actually do the clean. And let me actually do this, right? So that you see that the entire thing actually works, because at the very, very bottom, where you, for example, the place that uses the boundary is the controller, right? So the controller for the report, it uses the boundary, but we just made it private. Sure, we made it private for the report package, and the controller is in the report package, okay? In fact, this thing we can also make private. There we go. So I'm literally going to go through everything, okay, and make it private. Like this is the only one that we cannot do make private, right? So we can make the the implementation private, right? So because we're hiding the construction, but this one we cannot make private, right? This is the only one that you actually have a dependency on. This is probably some incremental compilation thing. It should not compile. Yeah, there we go. It should not compile. Well, let's do xgit compile. Well, okay, so let me just do this. Okay, this is exactly, exactly where your customs are, right? Exactly where you transition, and over here you actually need to have access to it. Okay, so this cannot be private, but literally everything else can. Okay, so we're here, the gate. Okay, like literally everything in here can be private, private, right? Like these guys are already private. Okay, in the end, we're gonna do a clean compile just to be sure. Everything is private over here. Same thing, private. Same thing, private. Boundary suite. Well, yeah. Well, this is, by the way, this is one of those things. Check it out. If we're running the tests, it's an easy way to. I actually want to make a short about this. I haven't recorded it yet. It's an easy way to ignore tests in Scala tests, at least, right? If you just make it private, Scala test is not going to find it. There you go. Okay. Right. So we cannot make this one private. Test suite. We cannot make this one private. Comparison. Okay, private. It's only important for the report. Comparison, control, like everything is private. Over here, it's already private. Over here, no. Google, this is just the implementation detail, private. Storage, same thing, private. Storage over here, same thing, private. Dependency graph. The dependency graph cannot be private. No, it cannot be private. Yeah, these things cannot be private. Well, technically, so in the report, well, it doesn't make sense to hide it, right? But like in the report, so in the report dependency graph over here, because nobody uses this, right? We can actually make it private, but it doesn't add anything because this trait is already private, right? Because we already said that nobody uses it, right? But you could, like in the beginning, you could just to like signal to your colleagues that, hey, nothing uses it, okay? So in the beginning, you can just do this, okay? What else? Yeah, that's it, okay? So look how many things we made private. We made like pretty much the whole thing private, right? So the controller is the only thing that stays public, right? Because it needs to be accessed accessed over here. Well, actually, does it need to be? Yeah, it does. It does. It needs to be, because otherwise it would escape this thing. Okay, so we need to be able to see this type on the outside, right? So that the main can actually see this type. In fact, maybe we actually don't. I'm thinking because nothing will. Let's try. I think we cannot make it private. Hold on. Let's clean. Yeah, we can. This is crazy, right? We can because we never need the type. We're sort of cheating here because we're using Scala's awesome type inference, right? Because over here, right, technically, over here we have, for example, the comparison controller, right? So we have it over here, right? And we're doing comparison controller dot run, right, like this, okay? Right. However, if you ask Metals, for example, to insert the type annotation, now it's going to say that it's not visible. Why is it visible? Oh, it is visible because I put it in a playground. Oh, yeah. Okay. Well, yeah, I guess. Yeah. This is not the point that I was trying to make, but yeah, it's cool as well. Yeah. So let's go back to this. Let's actually commit this. We're going to call it can't touch this, like this. Okay, and we're pretty much at the end. So let's go and do create. It's going to be called dev inside you. We're going to call it Law of Demeter, and it's going to be public. And please say yes to everything. I'm using the GitHub CLI, and I already have a video about this. If you want to, you might want to check it out. Okay, so now we just need to push the main branch. This is just a ZSH alias. Well, technically all my ZSH alias, right? It basically git push set upstream GP SUP. Okay, and now GH repo view in the web browser. There we go. So this is where it's going to be. The link is down in the description. You can look at all of the commits that we did. Where's the button? Keep moving things around. I think I can do commits. Yeah, there we go. Okay, so this is what we did today. Yeah, it's really, really awesome. I hope you enjoyed this video, and I really hope that you build your applications like this. It's very, very scalable. You can have a monolith with thousands and thousands of Scala files, and they will be always positioned in the correct place, always easy to find. It compiles like crazy because everything compiles in parallel, right? You've seen the dependency graph, right? Where is it again? Let's close this guy. Over here. Let's preview SVG. Okay, all of these things they compile in parallel, and you're going to keep adding them, right? You're going to keep adding them. You can easily have like 20, 30, 40. It really depends on your project, right? You can have all of them over here. They will all compile in parallel, right? As soon as this thing compiles, all of these guys compile in parallel, okay? And this one simply assembles them together. So it also assembles, it also compiles really, really fast. Cool. I really hope that you enjoyed this video. I see you in the next one. And for now, as always, it's been Vlad from devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you. And if you learned something today, consider supporting me on GitHub sponsors or Patreon, whatever you prefer. And also watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.